close your eyes for a moment. Think about the loudest wind you have ever heard. A storm maybe, a hurricane. The kind of wind that rattles your windows at 3 a.m. and makes you pull the blanket a little tighter. That wind was moving at perhaps 100 miles per hour. Now imagine a wind moving at 1,500 miles per hour. Not 150, not 500, 1,500. That is faster than a military jet at full afterburner. That is faster than a bullet fired from most rifles. That is faster than the speed of sound itself. Now, imagine that wind is not a storm. It is not an event. It is not an exception. It is the permanent, unending, planet-wide atmospheric condition of a world 3 billion miles from here. A world where that wind has been screaming without pause, without relief for longer than complex life has existed on Earth. This is Neptune, and we need to talk about what is actually happening there. Neptune was not discovered the way most planets were discovered. Nobody pointed a telescope at the sky and found it. It was found by logic. In the early 1800s, astronomers tracking the orbit of Uranus noticed something was wrong. The planet was not moving quite where the math said it should. Something was pulling at it, an invisible gravitational hand tugging at its path from somewhere deeper in the darkness. In 1846, two mathematicians, Urbain Le Verrier in France and John Couch Adams in England, working independently, both pointed at the same patch of sky and said, "There. Something is there. The math demands it." When astronomers turned their telescopes toward that exact spot, Neptune was exactly where the equations said it would be. It was the first planet ever predicted into existence by pure mathematics. Think about what that means. Before a single human eye had seen it, before a single photon from Neptune had passed through a single lens, Neptune was already known. The universe had been solved for it, and then, when we finally looked, it stared back. A cold blue eye, motionless, at the very edge of the sun's light. Neptune takes 165 years to complete one orbit around the sun. We discovered it in 1846. It completed its first full orbit since discovery in 2011. In the entire span of recorded human history, Neptune has not yet made 2 full laps around our star. It moves in agonizing silence. And it has been moving like this for 4.5 billion years. Now, let's talk about what is actually happening inside this silent blue world. Because silence is an illusion. The surface of Neptune, if you could call it a surface, is not calm. It is not still. It is a churning, screaming atmospheric engine running at a speed that has no equivalent on any other planet in our solar system. The wind on Neptune moves at up to 2,100 kilometers per hour. The speed of sound in Earth's atmosphere is approximately 1,235 kilometers per hour. Neptune's winds move nearly twice the speed of sound. Here is what that means in physical terms. Sound travels by compressing air, creating waves of pressure that push outward from their source. When an object moves faster than those pressure waves can travel, it outruns its own sound. It creates a sonic boom, a wall of compressed air, a shock wave. Neptune's winds are moving so fast that they would produce a continuous, permanent sonic boom across the entire face of the planet. If you were standing in those winds, which you could not, because you would be dead before you understood what was happening, you would not hear anything. The sound of the wind would be moving slower than the wind itself. You would be destroyed in silence. But here is the question that should be eating at you right now. How? Neptune is nearly 3 billion miles from the Sun. At that distance, our star is 900 times dimmer than it is from Earth. The solar energy reaching Neptune is almost nothing, barely a whisper of warmth across an immense frozen distance. On every other planet in our solar system, the energy for weather comes from the sun. Sunlight heats the atmosphere unevenly. Warm air rises, cool air rushes in to replace it, and wind is born. But Neptune gets almost no solar energy. So where is the power for winds moving 2,100 kilometers per hour coming from? The answer is buried deep inside Neptune itself, and it is one of the most unsettling mysteries in planetary science. Neptune radiates more energy than it receives from the Sun, significantly more. Measurements show that Neptune emits roughly 2.6 times more heat than it absorbs from solar radiation. Something inside Neptune is generating heat. The leading theory is that Neptune is still cooling down, still releasing the heat trapped inside it when the planet first formed 4.5 billion years ago from the collapse of a gas and dust cloud. The gravitational compression that built Neptune generated enormous heat, and that heat has been slowly leaking out ever since. But here is where it gets genuinely strange. Uranus-Neptune's near-identical twin, almost exactly the same size, the same composition, the same distance class from the Sun, emits almost no internal heat. Uranus is cold all the way through. Two planets built from the same material, formed in the same region, at the same time. One of them is a frozen, featureless ball. The other is a screaming atmospheric engine powered by an internal fire that by all rights should have gone out billions of years ago. Why is Uranus dead while Neptune burns? We do not know. Some scientists believe the massive collision that knocked Uranus onto its side, the same impact that tilted it 98 degrees, also expelled most of its internal heat in a catastrophic release. A single violent event that left Uranus thermally gutted while Neptune, spared from that particular catastrophe, retained its internal fire. But we have not confirmed this. What we know is this. Somewhere thousands of miles beneath Neptune's cloud tops, there is a heat source we cannot fully explain, powering winds we cannot fully model. On a planet we have visited exactly once for a few hours, 35 years ago. That heat rises through Neptune's layers, drives convection, and creates the most violent sustained winds in the known solar system. The winds are not a storm. The winds are the sound of Neptune's own heart, beating. In 1989, Voyager 2 arrived at Neptune after a 12-year journey across the solar system. It had only hours to make its observations. Hours to study a planet that had been waiting for 4.5 billion years. And what it found stopped scientists cold. On Neptune's southern hemisphere, there was a storm. Not a small storm, not a regional weather event, a hurricane the size of the entire Earth, an oval of swirling darkness that Voyager 2's instruments measured, photographed, and sent back to a stunned team of scientists at JPL. They called it the Great Dark Spot. It looked like Neptune's answer to Jupiter's Great Red Spot, that ancient, permanent storm that has been raging on Jupiter for hundreds of years, a fixture of the solar system as reliable as the Sun itself. Scientists assumed the Great Dark Spot was the same, ancient, permanent, defining. They were wrong. When the Hubble Space Telescope turned toward Neptune 5 years later, in 1994, the Great Dark Spot was gone. Not diminished, not weakened, gone, and in its place, in a completely different hemisphere, a new storm had appeared. Neptune's storms are not permanent fixtures. They form, they grow to the size of entire planets. They dominate the atmosphere for years, and then they vanish, dissolved back into the screaming winds as if they were never there. On Jupiter, a storm can last centuries. On Neptune, a storm can be born and die within a human lifetime. The same winds that power these storms also destroy them, shearing them apart when the atmospheric conditions shift in ways we still do not understand. Neptune breathes. On the scale of years, on the scale of decades, the planet's atmospheric patterns shift and churn and reorganize. And we have been watching long enough to catch just one breath. Now go deeper. Past the supersonic clouds, past the convection columns driving the winds, down into the true interior of Neptune, where the pressure becomes something that human engineering cannot reproduce and human intuition cannot grasp. At about 7,000 kilometers below the cloud tops, the pressure reaches approximately 200,000 times the pressure at Earth's surface. At that depth, Neptune's atmosphere transitions into something that is not quite a gas and not quite a liquid. A dense, hot fluid of water, ammonia, and methane, compressed under conditions that make the materials behave in ways they never behave anywhere accessible to us. And here, in this crushing hot darkness, the carbon atoms scattered throughout Neptune's methane, begins to transform. Under sufficient pressure, carbon atoms are forced into a crystalline lattice. They lock together in the most precise geometric arrangement possible. Diamond. Scientists believe it rains diamonds inside Neptune. Not metaphorically, not approximately. Actual diamonds' carbon crystals, potentially as large as boulders, forming in the superheated fluid and falling through thousands of kilometers of crushing pressure before reaching the inner core. Laser experiments at the National Ignition Facility have actually replicated the interior conditions of Neptune in miniature and confirmed that diamond formation occurs. The diamonds are real, the rain is real, but they do not accumulate on a surface. They fall through a scorching liquid ocean of metallic fluid and melt back into the mix, releasing heat that rises upward, driving convection, ultimately powering the winds. The diamonds that rain inside Neptune are, in a very real sense, fuel. The most expensive material on Earth falls like rain inside an ice giant 3 billion miles away and burns. And beneath all of this, beneath the diamond rain, beneath the fluid ocean, buried at the center of Neptune, is a core of rock and ice, compressed to a temperature of approximately 5,100 degrees Celsius, hotter than the surface of the sun. This is the frozen planet. The cold blue world at the edge of the solar system, cold on the outside. A furnace at the center. A furnace that has been burning for 4.5 billion years and shows no sign of stopping. But Neptune is not alone. It has 14 known moons. And the story of the largest one is not a story about a moon at all. It is a story about a kidnapping and a slow, inevitable execution. Triton. Triton is wrong from the moment you look at it. Every large moon in our solar system orbits its planet in the same direction the planet spins. This is not a coincidence, it is a consequence of formation. Moons that form alongside their planets inherit the same rotational direction from the disk of gas and dust that created the whole system. Triton orbits Neptune backward. It moves in direct opposition to Neptune's rotation, what astronomers call a retrograde orbit. No large moon formed in place does this. The physics does not allow it. Triton was not born here. The leading theory is that Triton was once a free-floating Kuiper Belt object, a world of ice and rock orbiting the Sun independently in the outer solar system, its own master on its own path. Billions of years ago, Triton wandered too close to Neptune. Neptune's gravity reached out. What followed was not a clean capture. It was a violent gravitational interaction, likely involving a third body, that bled away enough of Triton's orbital energy to trap it. The original moons of Neptune were almost certainly destroyed in the chaos of this capture, smashed apart by the gravitational disruption of this intruder. Triton arrived and murdered the family it was forced to join. Today, Triton is 2,700 kilometers across, larger than Pluto. Its surface temperature is -235 degrees Celsius, making it one of the coldest surfaces in the solar system. And yet, beneath that frozen face, there are geysers. Dark plumes of nitrogen gas erupt from the South Pole, shooting kilometers into the thin atmosphere before being swept sideways by the wind. A frozen world, actively venting, alive, in its own terrible way. But Triton's retrograde orbit is its death sentence. Every orbit, tidal friction, steals a small amount of Triton's energy. Its orbit is decaying slowly, measurably, irreversibly. In approximately 3.6 billion years, Triton will cross Neptune's Roche limit. And Neptune will do to Triton exactly what we discussed at Saturn. The tidal forces will overcome Triton's self-gravity. The moon will come apart first, the outer layers, then the mantle, then the core. The fragments will spread into a ring system that will dwarf anything Saturn currently wears. Neptune will wear Triton as a crown. A world that once roamed free through the outer solar system, that survived billions of years of independent existence, kidnapped and slowly strangled, will become decoration for the planet that captured it. There is nothing Triton can do. The math was written the moment Neptune's gravity closed around it. We have sent one spacecraft to Neptune. 1. Voyager 2 flew past in August 1989. It had approximately 6 hours at close range before Neptune's gravity flung it onward toward interstellar space. 6 hours to study a world that had been waiting for 4.5 billion years. Everything we know about Neptune in detail, the winds, the great dark spot, the geysers of Triton, the rings, comes from those 6 hours. 6 hours. Since then, Neptune has been observed only from a distance. By Hubble, by ground-based telescopes, by instruments that can tell us something is happening there, but cannot tell us what it means. There are proposals, missions called Triton, Odyssey, but none have been approved, funded, or launched. As of now, no mission is scheduled to reach Neptune for decades. The most violent atmospheric planet in our solar system. A world with an internal fire we cannot explain. Diamond rain we cannot reach. A kidnapped moon on a death sentence we cannot reverse. And we have given it 6 hours. Think about that the next time you feel like we have explored space. We have scratched the surface of the nearest planets. We have barely acknowledged the existence of the ones that lie beyond. Neptune exists at the edge of what we call the solar system, in a darkness so deep that the sun is just another star, a slightly brighter point of light among billions. Out there, right now, the winds are screaming at 2,100 kilometers per hour. They have been screaming since before the first fish developed legs and crawled onto land. They will be screaming long after the last human thought has faded from the universe. And we have never stood there to hear them. We have never stood anywhere close. 3 billion miles of empty space, and we sent one robot for 6 hours 35 years ago and called it a visit. Neptune does not notice. It has been there for 4.5 billion years. It will be there for billions more, screaming into a void that does not care. And the most terrifying thing about it is not the winds. It is the fact that we have barely looked,